According to Nietzsche, very few individuals possess a genuine concern for truth or factual accuracy. Rather, the majority of people are primarily preoccupied with appearance, comfort, security, and power. This insight led the philosopher Joseph Schieber to articulate what he termed the Nietzsche thesis, the claim that the principal aim of most conversations is not the pursuit of truth but rather self preservation. In this view, individuals accept or reject claims on the basis of strategic calculation rather than from any intrinsic commitment to truth itself. As Nietzsche observed, truth is sought only when it carries pleasant or life preserving consequences. Conversely, truths that threaten stability or well being are resisted or ignored. One relevant observation from the contemporary society that seems to support the Nietzsche thesis is the widespread appeal of conspiracy theories and echo chamber discourses. If people genuinely value truth, they would readily interrogate and fact check the distorted claims that frequently circulate in public culture. However, what we find instead is a tendency to accept assertions delivered by charismatic speakers, often without critical scrutiny. Acceptance tends to augur not because of evidence, but because such claims reinforce an individual's self interest, social standing, or group belonging. People are inclined to affirm what others around them affirm and to align with narratives that preserve social harmony or status, regardless of their factual reliability. Human beings are not only poor at handling facts, but if Nietzsche's diagnosis is accurate, largely indifferent to them. What we value more consistently is not truth itself, but the preservation of comfort, identity, and well being. What if the universe is not just stars, planets, and galaxies scattered through space? In 2020, a study by astrophysicist Franco Vazza and neuroscientist Alberto Fletti compared the large scale structure of the universe with the network of neurons in the human brain. To their surprise, the two looked remarkably similar when placed side by side. The map of galaxies in the cosmic web and the map of neural connections showed identical patterns. The human brain contains nearly 86 billion neurons, while the observable universe has around 2 trillion galaxies, all interconnected through invisible filaments of dark matter and energy. This linkage resembles the way neurons connect with one another, but on a cosmic scale. Even more intriguing, both the brain and universe seem to exchange and distribute energy in comparable ways. This raises a thought-provoking possibility. Perhaps we are not only living in the universe, but also existing within a vast living system like tiny cells within a much greater cosmic organism. And maybe in some way we are part of its thoughts.
Isha, you had a question.
Yes, sir.
Please ask.
Sir, Earth travels 52 million kilometers daily through space, yet we don't feel the speed. Why?
Okay, it's a very nice question.
Earth's motion is incredibly fast but very smooth and shared by everything around. Body sensors feel changes in speed or direction. That's acceleration, not steady motion. And Earth's acceleration are tiny compared to gravity. Rotation. In case of rotation at the equator, the surface moves eastward about 1670 km per hour, approximately 465 meters per second, decreasing towards the poles, where it becomes nearly zero. And when it orbits around the sun, the average speed of Earth is about 300 kilometers per second, which is nearly 108,000 kilometers per hour. And through the galaxy, the solar system orbits the Milky Way at roughly 220 kilometers per second. The inner ear and body senses acceleration, not constant velocity in physics. Constant velocity is indistinguishable from rest if there are no external cues, so steady motion produces no push. Earth's rotation and orbital motion are extremely uniform, so the acceleration that would trigger sensation are minimal over short times. The centripetal acceleration needed to keep at the equator due to Earth's rotation is only about 0.034 meter per second square, roughly 0.3% of gravity. Too small for ordinary sensation. This makes weight vary slightly less at the equator than at the poles, but the difference is subtle and felt only with instruments. The atmosphere largely co-rotates with Earth. Near the surface, air moves almost exactly with the ground because of gravity and frictionless coupling. So there is no massive headwind from rotation. In orbit around the sun, there is no surrounding air to rush past. Space is vacuum, so no wind is created by that motion. Perception relies on nearby reference points to judge movement. Distant stars change position very slowly across the sky, so the eyes and brain get no immediate cue that indicates high speed. A smooth, straight train ride at constant speed, everything inside moves together and there's no sense of speed, only acceleration when the train stops, starts or turns is felt. Earth's motions are like the smooth ride.